So far we've been dealing with exponential situations, and we have been dealing with exponential growth and decay, and we've been using the formula y equals a times b to the x. We're still going to be doing that, but usually we've been dealing with something that doubles or triples. Well, sometimes things grow by percentage, so that's what we're going to be looking at next. At the end of this lesson, you'll be able to write an exponential function to model an exponential situation that involves percent growth or decay. Alright, so let's look at problem number 1. It says you deposit $1,500 in an account that pays 5% interest yearly. And this happens a lot if you have a savings account or anything like that where you're letting your money grow. It is an exponential situation, and it's not just a straightforward doubles or triples or quadruples or something like that. So we're going to be writing an exponential function to model this situation. Well, we know that definitely we're going to start out with y equals a times b to the x, because it is an exponential situation. If you recall, a is going to be our starting amount. I'll just write this down just in case you want it. And then b is going to be our growth rate. Alright, so when we go to write our equation, we're going to have y equals our starting amount. We are depositing $1,500 into the account. So it's going to be 1,500 times, now this is where it's going to get a little tricky for this one. First of all, if I have 5%, probably from dealing with percents before, you know that we should change it to a decimal. So if I have the decimal at the right side, if I move it over 2 places as a decimal, that would be 0.05. And what's going to happen when something grows, it has its whole percent, which would be 1, but then it's going to add this much more. So we are going to do 1 plus 0.05. That's going to be our growth rate. So I'm going to put 1 plus 0.05 there. Okay, I'm going to rewrite that though, so this will actually be y equals 1,500 times, if I add the 1 and the 0.05 together, I'll get 1.05 to the x. And notice we want it to grow, so that number needs to be bigger than 1, and it is. So that's my equation. And then it says, how much money will you have after 6 years? Well, now all we need to do is plug our number into that formula. So it's going to be 1,500 times 1.05 raised to the 6th power. And if you find that answer on your calculator, it will be worth $2,010.14. So that's how much we would have after 6 years. I put parentheses in this problem. You don't necessarily have to. When I'm working with decimals, I generally like to put things in parentheses, but it's totally up to you. Alright, I'm going to read this problem, but then what I would like you to do is pause the video and see if you can figure it out on your own. Get as far as you possibly can, and then come back and watch the answer. Right, the owner of a 1953 Hudson Hornet convertible sold the car at an auction. The owner bought the car for $11,000. The value of the car increased at a rate of 6.9% per year. So if it increased, it went up. So we know we're going to have growth. All right, we know it's an exponential situation because it's increasing by same amount every year. We know that we're going to start with y equals a times b to the x. And the initial amount, the a, would be the starting amount, which is going to be 11,000. So this is going to be y equals 11,000 times. Now, if we want it to grow, first of all, 6.9% as a decimal would be 0.069. If I want it to grow, we're going to do 1 plus 0.069, because that will give me a number bigger than 1. And then if I rewrite this, we'll have y equals 11,000 times 1.069 raised to the x power. Now if you want to, if you're getting good at these, feel free to skip this first equation. We really just want this final equation as our answer. Alright, so that's the first part. Then the owner sold the car at the auction 20 years after he bought it. What was the value of the car at the time of the auction? So now we can just plug 20 into our formula. So we'll have 11,000 times 1.069 raised to the 20 power. And again, you can type that in your calculator. And if you do so, you'll get that the car was worth $41,779.92. So it grew quite rapidly there. All right, problem number 3. A mouse population is 25,000, and this time is decreasing in size, fortunately, at a rate of 20% per year. So we're decreasing the size this time, so I need my answer to be less than 1 instead of greater than 1. So first of all, 20% as a decimal is going to be 0.20, and we're still going to start out with y equals a times b to the x. And in this case, we'll have y equals A, which is my starting amount. We started with 25,000 mice. And then my growth rate, this time before, to get a number bigger than 1, we did 1 plus the rate. This time we're going to do 1 minus the rate. So we're going to do 1 minus 0.20 raised to the x power. And I'm going to rewrite that. We'll have y equals 25,000 times 1 minus 0.20 is 0.80 to the x power. So this is my formula. Instead of adding 1, we do the subtracting 1. And then if we want to know what is the mouse population after 3 years, we just plug it in our formula, 25,000 times 0.80 raised to the 3. And if we type that in our calculator, we will unfortunately still have 12,800 mice, but at least the number is going down. When you did this problem, you don't necessarily have to have the decimal. Another way that somebody might write this problem would just be 0.8 to the x instead of 0.80 to the x, and we might not have parentheses. Both of those are correct. Problem 4. This one, again, I would like you to pause the video, try it on your own, or get as far as you possibly can, and then come back and revisit and see how you did. All right, you purchased a cell phone for $125. The value of the cell phone decreases by about 25% annually. So again, we've got something that is decreasing, so we need the growth rate to be less than 1. We're going to start with y equals A times b to the x. 25% as a decimal is 0.25. So we're going to have y equals A as our starting amount. Our starting amount is $125. And then times, since I want it to decrease instead of adding 1, I'll do 1 minus 0.25. So it's going to be 1 minus 0.25 raised to the x power. So we'll get y equals 125 times 0.75 to the x power, because 1 minus 0.25 is 0.75. Again, you can have parentheses or not have parentheses. It doesn't make a big deal. The biggest thing is that the x has to be the exponent. So that's the formula. And then from here, if we want to find the value of the cell phone after 5 years, we'll just plug 5 into our formula. So we'll have 125 times 0.75 to the 5th power. And again, we can just plug that right into our calculator. And when we do this, it will be worth $29.66. So hopefully now you can write an exponential function involving an exponential situation that is decreasing or increasing by 1%.